We're going to move from equalities to inequalities. So let's take a look at some of the differences and similarities here between equalities and inequalities. So when I say the word equality, that means that I'm talking about something that has an equal sign in it. Okay? So 2x plus 4 equals 7. When I'm talking about an inequality, I'm talking about a less than or greater than symbol. Could have a less than or equal to or greater than or equal to symbol. Okay? So those are equalities and inequalities. Ways that they're similar. In solving a linear equality, the goal is to get the y by itself. It's the same goal. In an inequality, you just want to get the x by itself as well. Okay, you're just trying to get that variable, all the stuff around it, away from it. And you're going to continue getting it away from it by using SADMAP. Which is, again, just PEMDAS backwards. I want to get rid of all of that stuff, get rid of fractions before I start doing anything else, those types of things. Ways that they're different are some extremely important things. When I am dealing with an inequality and I multiply by a negative, the inequality has to switch. I go from one side of the number line all the way to the other side. I go from a positive number to a negative number. Okay, so then what ends up happening is that the inequality has to go the other direction. So instead of it going to the right, the whole thing flips and it has to go to the left. Same thing happens when I divide by a negative. If I divide by a negative, then the inequality is also going to switch. And the biggest thing, so that's kind of a technical thing that happens, but the biggest thing that you need to understand concept-wise is that when you have an inequality and you solve it and you get x is greater than 4, you have an infinite number of answers. When I was solving an equality and I said x equals 4, you knew that x equals 4. That's the only option for you. When I solve an inequality and it's x is greater than 4, we could sit here all day, come up with numbers that are bigger than 4. Okay, and so it's an important thing that you understand that an inequality has an infinite number of answers. And so when we talk about an inequality, in most cases, we're going to end up graphing with it. We're not going to spend a lot of time with that in this situation, but it's important for you to know that. So when I look at number 5 here, a nice one-step equation where I've got x minus 3, I'm going to treat this inequality just like it was an equal sign. So I'm going to add 3 to both sides here. And so I get x less than 2 plus 3 is 5. Okay, when I look at that, I'm looking at all the numbers that are less than 5 will work in this problem. So I can take the number 2. 2 is less than 5. So I could plug that in and I get 2 minus 3 is negative 1. That's less than 2. Okay, so I can take any number that is less than 5, plug it in, and it's going to come out to be less than 2. All right, so any number less than 5 is my answer. I didn't multiply or divide by a negative, and so I didn't have to do anything with the inequality. I didn't have to switch it or anything like that. Well, what we need to do with this situation is that we're also going to graph these. So, what I want you to do at a minimum is place this number on the number line in the middle, and then I want you to put a number that's bigger than that and a number that's smaller than that. So a number bigger than 5 is 6, a number smaller than 5 is 4. Okay, so that's as easy as putting the next number that's next to it. But then I need to decide if this is an open or closed circle. Am I including 5 or am I not? If I'm not including 5, that's going to be a less than or greater than situation. So if I have less than or greater than, I have an open circle. If I have a less than equal to or greater than equal to, that's going to give me a closed circle. And it's open because I'm not including it. Okay, it goes all the way up to that point but doesn't include it. It's closed because it is included. The equal sign means that it is included. Equals. It equals that. Okay, so this is x is less than 5, so we've got an open circle at 5 because it's less than. And then I actually want to draw an arrow in the direction that's less than. So I want all the numbers that are less than 5. Well, 4 is less than 5, and all the numbers that are to the left here are going to be less than 5. Okay, so that's what my answer looks like for number 5. Some of these problems you're going to have to do use a little bit more space in them. Number 7, I've got 4x less than or equal to 8. So I need to divide by 4. That's my one step. I divided by a positive 4, and so nothing really happens with the inequality. X is less than or equal to 8 divided by 4 is 2. Okay, so there's my answer. X is less than or equal to 2. I need a number line here. I've got 2. A number that's bigger than that is 3. A number that's smaller than that is 1. Less than or equal to. Equal to means I've got a closed circle, so I've got a closed circle here at 2. Numbers that are less than 2 are to the left. Okay, numbers that are less than 2 are to the left. Let's jump down to number 9. It's still a one-step equation. I'm going to divide this side by -2 and divide this side by -2. I get x on the left-hand side. 8 divided by -2 is -4, but I've divided by a negative. When you divide by a negative, you have to flip the sign. So it was greater than, now it's less than. So it's an important idea. Okay, x is less than -4 then is what I want to be graphing. So I've got my graph here. I've got a 4. One number that's bigger than that is a 5. A number that's smaller than that is a 3. You can choose any numbers for that. Okay, I don't care. If you say, well, I also know that 100 is bigger than 4. That's true. And I also know that -1000 is less than 4. That's true. Okay, I just need a number that's less than 4 and a number that's bigger than 4. -4, rather. Okay, so I'm looking for the numbers that are less than -4. I be careful when you're using the negatives here as answers. That if you were to plug in -5 here and -3 here, that is not correct. Okay, it's not correct because -4, it does not fall in between -5 and -3 in that way. -3 is actually bigger than -5. And so the -3 should actually go on this side. Whoops. The other side. -3 should actually go on this side, and -5 should go on this side. Okay, as I go to the left, I get smaller. -5 is smaller than -4. So x is less than -4, open circle, and less than is still to the left. Okay, so my graph looks like that. You need an answer and a graph. Okay, let's move down to a couple problems that are a little bit more difficult. Here's this two-step problem in number 15. I need to add 2 to both sides. So I get 5x less than or equal to 10. Divide by 5. And I'm going to cross this out for more space. I get x is less than or equal to 2. I divided by a +5, so I don't need to switch the inequality. X is less than 2. Here's my number line. I've got a 2 here and a 3 and a 1. Less than or equal to, closed circle. All of the problems that I've done so far are less than. Let's find one that's going to come out to be greater than. But there's your graphs. You need an answer and a graph. Let's find one that's going to come out to be a greater than symbol here. How about number 19? When I look at number 19, I've got x's on both sides. It doesn't change just because I put an inequality there. I'm still looking at trying to solve this by doing the same steps. So I subtract 2x from both sides. 6x plus 1 greater than or equal to 13. Now I've got a nice two-step equation. I'm going to subtract 1. 6x greater than or equal to 12. Divide by 6. And x is greater than or equal to 2. I divided by a positive number, and so I ended up with not switching the inequality the whole way. So I end up with x is greater than or equal to 2. So here's my number line. I've got a 2 and a 3 and a 1. Closed circle at 2. X is greater than or equal to. Equal to part is closed circle. And then I want the numbers that are bigger than 2. That's to the right here. And so we're going through, we're solving all these problems. This page continues with the same logic behind them. I'll take a snapshot of one of these and do this problem on a separate page because there's zero way that you could fit this in on the page that we were currently on. So let's take a look at this one, number 41. Number 41, I've got a couple things with distributive property in here. So I've got 2, I multiply negative 5 times x and negative 5 times 1. That multiplication does not count in order for me to switch the sign. That multiplication, yes, I'm multiplying by negative 5, but I'm not multiplying both sides by negative 5. Okay, so it doesn't affect my multiplication over here. So I've got 2 minus 5 on the left-hand side. So negative 5x minus 3 greater than or equal to 3x. Negative 3 minus 8 is negative 11. I've got variables on both sides. Here's where moving the smaller one is going to help you out. So I move the smaller one. Negative 3 greater than or equal to 3x plus 5x is 8x minus 11. Nice friendly equation. Add 11 to both sides. Gives me 8 greater than or equal to 8x. Divide by 8. And I end up with 1 is greater than or equal to x. Now be careful with this. Okay, I've got a 1 here and a 2 and a 0 or whatever numbers you want. One bigger, one smaller. Now the x is the place that I'm plugging in numbers. So I want all the numbers where 1 is bigger than all of them. Okay, this says 1 is bigger than all the numbers that I have. And so I've got an open circle, closed circle at 1 rather. Okay, there's an equal to there. I want all the numbers that where 1 is bigger than those. Okay, and so another way to write that is to switch this around. Put the x on this side. The arrow is pointing towards the x, so I want the arrow to point towards the x over here. And I have x is less than 1. I want all the numbers that are less than 1. Or I want 1 to be the biggest of all the numbers. And so that actually looks like this on the graph. The arrow is going to go to the left. Be careful when you're making the graph. Okay, just because the work came out to be some way and you automatically think that greater than means to the right, it's not. In this case, all the numbers that I want, 1 is bigger than all of them. Okay, or all the numbers that I want are less than 1. Okay, that would be another way to write that. So either this one or this one, and here's the graph. Okay, so make sure that you're going through just solving these problems, doing some nice two-step equations, some nice equations with variables on both sides, some nice inequalities, being careful with the multiplying and dividing, by a negative if you have that type of a situation. We're looking at the assignment with this is we're going to be doing the assignment that's that your quiz is going to come from is going to be the odds 5 through 45, the odds. So take a look at those odd problems, go through, make sure that you're able to solve them, make sure that you're able to understand when you're supposed to multiply by or when you multiply by a negative on both sides, when that inequality actually switches and goes the other way. Make sure that you understand how the graphing works, so that if I give you multiple choice for graphing, that you're able to pick the correct graph for the correct answer.